Welcome to This Explainer. We're going to completely demystify that stack of blinking hardware sitting right there in your home or office. We all use the internet literally every single day, right? But how often do we actually stop to think about the invisible infrastructure making the whole thing happen? Today, we're tracing the fascinating journey of digital data by looking closely at three specific devices: the hub, the switch, and the router. So think about it. How does a simple email leave your laptop and cross the globe? Well, let's dive right into that by looking at the exact devices that make localized and global internet connections actually possible. When you hit send, your data doesn't just, magically teleport to its destination. It's embarking on this epic journey, relying on very specific hardware to route it step by step. To understand how this all works, here's our roadmap for today. We'll start with the hardware behind the network, then look at hubs as clueless broadcasters, switches as the smart upgrades, routers as internet gateways, and finally, connecting the whole world.
Starting with Section 1, the hardware behind the network.
Now, if you look at a hub, a switch, and a router side by side, they all look pretty much identical. They all have multiple ports, and they all accept standard Ethernet connections from your devices. But the big secret separating them, it lies entirely in their internal intelligence and how they actually process the data coming through those cables. Moving to Section 2, hubs, the clueless broadcasters. So the main purpose of a hub is simply to connect your devices together locally. Think of the hub as a totally clueless broadcaster. It has absolutely zero intelligence about where data is supposed to go, and it doesn't filter anything. It's basically the network equivalent of that one coworker who always hits reply all on a company-wide email. The only thing a hub actually knows is when a device is physically plugged into one of its ports. And because of that total lack of intelligence, when a data packet arrives at one port, intended for a specific computer, the hub just copies and rebroadcasts that packet to every single port on the device. It just shouts it out to everyone. So even if computer A only wanted to talk to computer B, well, all the other computers plugged into that hub are still going to get that exact same data packet. As you can imagine, this messy approach creates some serious issues. Because everyone on the hub sees data meant for just one person, you immediately run into major security concerns. On top of that, copying and blasting all this data to every single port generates a massive amount of totally unnecessary network traffic. It just completely wastes your network's bandwidth. Which brings us to Section 3, switches, the smart upgrades. Now, a switch looks just like a hub on the outside, taking those exact same Ethernet connections. But unlike a hub, a switch is highly intelligent. It acts like a meticulous record keeper. It actually learns and records the unique physical addresses, known as MAC addresses, of every specific device plugged into it. It stores all of these addresses right inside its own internal table. This radically changes the game for how your data is handled. When a data packet arrives at a switch, it doesn't just blindly shout it out. Instead, the switch checks its table of MAC addresses and matching ports, finds the exact match, and delivers the data packet exclusively to the correct port. So only the intended computer gets the message. This brilliantly illustrates the massive upgrade you get with a switch. By sending data only to the specific intended destination, it completely eliminates all that unnecessary traffic we saw with hubs. Because of this, switches are vastly preferred for pretty much any local area network, whether that's your house or a massive corporate office, because they keep things secure and highly efficient.
All right, Section 4, routers, the internet gateways.
So hubs and switches are great locally, but to exchange data outside of your own network, a device absolutely has to be able to read IP addresses. Since hubs and switches only deal with physical connections and MAC addresses, they can't read IP addresses at all. They're stuck locally. So we have to introduce our ultimate network hero to make global communication happen. Enter the router. A router does exactly what its name implies. It routes or forwards data from one network to another based on IP addresses. When it gets a data packet, it actively inspects that data's IP address. It figures out if the packet is meant for its own local network or if it needs to be sent off somewhere else entirely. Basically, it acts as the exclusive gateway or the bouncer of your local network. To visualize this, let's imagine a private setup called the Red Network. The router stands right at the door inspecting incoming internet data packets of all different colors that represent different IP addresses. The router is only going to accept the red data packets because they match its IP address and actually belong there. It just outright rejects the yellow, blue, and green packets.
Finally, Section 5, connecting the whole world.
Right now, all across the globe, local networks are using hubs and switches to happily exchange data internally. But to talk to different networks globally, they have to hand that data off. They rely entirely on their routers to bridge the gap, taking local requests and pushing them out onto the wider internet.
So here is the exact step-by-step journey if a computer on that red network wants to talk to one on the blue network. First, the data packet leaves the local computer and hits the red network's router. The router checks the destination IP address and forwards the data out onto the internet. It makes its way across the web until it reaches the blue network's router. That router accepts it, passes it down to its local switch, and boom, it safely arrives at the intended computer.
To really lock in everything we've talked about today, here is a quick visual cheat sheet contrasting how these three devices handle your data. Hubs are totally clueless. They don't use any addresses, and they just blast data locally. Switches are the smart ones, using physical MAC addresses to securely exchange data locally. And routers? They are your gateways, using IP addresses to seamlessly connect entirely different networks together.
This quote from our source material perfectly distills the whole concept down into one sentence. Hubs and switches are used to create networks, while routers are used to connect networks. You need hubs and switches to build the foundation of your local network, but it is the router that acts as the essential bridge, linking all those isolated networks together to form the modern internet. Every single box plays a critical role. I really hope this explainer has totally demystified your home setup. Next time you glance over at those little boxes with the blinking lights, you'll know exactly the silent, intelligent, and highly coordinated work they're doing just to keep you connected. Leaves you wondering, right? Just how many different routers did your data bounce through across the globe in the exact millisecond it took to load this explainer? Thanks for joining me.